Okay, so like I was saying before, we're talking about conics. Today we're talking about two specific conics, a circle and an ellipse. And those are pretty related in the same way like a square and a rectangle are related, right? Every square is a rectangle, but not every rectangle is a square. And this is going to sort of follow that same line of reasoning. Every circle is an ellipse, but not every ellipse is a circle. So a circle is sort of like the square in this case, and the ellipse is sort of like the rectangle. So let's talk about the simpler of the two objects, which is the circle, okay? So let's let HK be some point, be the center. And let's let R be the radius. So the formula that we're going to use for a circle is pretty straightforward. There's not a lot to it. It's just this. X minus h squared plus y minus k squared equals r squared. So what we're going to do is we're going to build this circle in Desmos just so you can see really easily how these different parameters are going to change the shape and well, not, I guess not the shape, but the size and location of the circle. So go ahead and if you haven't already, log in to Desmos. Or you don't have to actually log in, just get to desmos.com. So yeah, we're going to want to go to desmos.com. And just click Start Graphing. Okay, so what we're going to do is just type in just the generic formula, what I call like the conic form of this formula for a circle. So I'm going to type it in exactly how we wrote it. X, let's see, minus h. And then we're going to add a little slider here. Okay, so we can sort of change the value of h to meet our needs. So there can be a little slider there. Let's see, how am I going to do squared on here? There we go. So squared. So there's a little like up arrow, like a little caret. If you click on the little symbol, you come up with all these choices. Or you're using a keyboard, so you can just type it. Let's see, plus. Where's plus on here? Come on. Y minus k. And we're going to add a slider for k too. So basically, all the values that we're going to be changing, we're going to add a slider for, so you can just easily change it. You don't have to retype the equation or anything. We can just change those values as we need to. So we want that to be square. Oh, not to the w. Yeah. Okay. Equals r squared. So r will want a slider as well. Okay. So there we go. So we got the equation right here. That's our formula. We've got all three of the parameters here that would be like constants that you plug in. And then the graph. So once you get that in, just take a minute and just play with the sliders a little bit. Watch how, as I change x, that's going to change the horizontal alignment of my circle, right? That's changing the x coordinate of the center. Yeah. As I change k, that's changing the y coordinate of the center. So like if y is 2, it'll be centered at y equals 2. So you could move it up, down, left, right, and then the R value is the radius. So that's going to control how big the circle is, right? As I increase that radius, you can see it makes our circle either bigger or smaller. Yeah. Now, if we want the unit circle, I know you guys love the unit circle. The unit circle is centered at the origin and has a radius of 1. So if my HK is 0, 0, and my radius is 1, that right there is the unit circle. So that's just kind of interesting. So you can use Desmos if you'd like, but what I'd like for you to do is try to sketch out a graph of an equation I'll give you. So like, let's say I say graph x minus 2 squared plus y plus 1 squared equals 25. So you could definitely move those sliders around if you don't want to like think about it. But try to figure out, like, what I want you to do is before you start moving the sliders around and putting the equation into Desmos is see if you can sketch out this graph on your own. All right. So what are some of the important pieces of information in this equation?
Well, we know the radius is 5.
Okay, so how did you get that?
Well, we had 25 where r squared should be, so square root of 25 is radius.
Okay, so the radius would be the square root of 25, which is 5, right? And then where is the center? You want to be careful there, okay? Notice how the equation is x minus h and y minus k. So the h and k are going to have the opposite sign of the coordinates of the center. So like what should be the x coordinate of the center? Yeah, positive 2, comma, negative 1. So when you go to sketch it, zoom in here, I don't know why it's so yellow up here. So 2, negative 1. Here's where the center is. I'm going to do an open circle because that's not actually part of the circle itself. The radius is 5, so I'm just going to count 5 units up, 5 units down, 5 units to the left, 5 units to the right, plot those 4 points, and then do the best I can to sketch out a circle. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I've got points here and here, roughly. I mean, this is just a sketch. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is going to be a pretty crummy sketch here, but here's my circle. And if we go back to Desmos, we can test that out. All right, I'll go back to the notes in just a sec. So we've got x minus, what did I say, 2. Oops, the h is 2. Come on. There we go. And the k was negative 1. And the r value we said was 5. So there you go. That's really what the circle should look like. That seems all right. It's not a bad sketch. Okay, it's not great either, but there you go. Yeah. Do y'all have any questions about circles? All right, so circles are kind of the easiest one to think about. Let's get into one that's a little bit more complicated, which is the ellipse. Okay, so let's talk about ellipses. Okay, so an ellipse is basically an oval. Okay, it does have a specific definition, and we'll get into that probably on the last day when we would sort of technically define everything. But for today, I just want to show you what the equation is, what the parameters represent, and then how to graph it. So an ellipse, let's say, let HK be the center of the ellipse. Okay. Now these ellipses are going to have two different axes. We're going to call them the major axis and the minor axis. Essentially, unless it's a circle, the ellipse is going to be longer either up and down or left and right. And depending on which way the ellipse is oriented, your equation is going to look just slightly different. Okay, so what I mean by that is you can have an ellipse, like an oval, which is longer than it is wide, right? So like the horizontal axis here would be larger than the vertical axis. Or you can have one that is sort of tall and narrow. So you can have an ellipse that's sort of oriented like this. So you've got the short and fat or the tall and skinny. Yeah. So let's go over like what the equation will look like here. It'll be kind of similar to the circle equation, except each one of the squared binomials is going to be divided by a certain number. So that's really the only difference here. So it'll look very similar, but each of the squared binomials will be divided by something. Another thing that's going to be different about the ellipse equation versus the circle equation is that for the ellipse equation, it'll always equal 1. Okay? So let me just go ahead and give you the equations, and then we can start sort of picking apart what everything means in it. So for the short and wide, it looks like this. X minus h squared over a squared plus y minus k squared over b squared equals 1. Okay? This is the case where the major axis is horizontal. Okay, we do have a minor axis, and it's the vertical one. And these two axes should intersect at the center. Right here. Now, for the ellipse, this a parameter is always going to be the bigger number. Okay? So whatever number is bigger, if it's underneath the x, then the horizontal axis will be larger. But if the larger denominator is underneath the y, then your vertical axis will be bigger. So really the only difference between the equation we're going to use for this one and the equation we will use for this one is about like which number is bigger underneath each of these fractions. So I'm going to go ahead and write this one. X minus h squared over b squared plus y minus k squared over a squared equals 1. So they're very similar. The only thing that's swapped out are these denominators. Okay, so we're going to make a couple notes here. Note that a is always bigger than b. No questions asked for the ellipse. Okay, so that is sort of a condition. For this vertical ellipse, the major axis is vertical, and the minor axis is horizontal, with the center right here. Center is your HK. Now, A and B mean something very specific in these ellipses, and they're going to tell you basically how wide or how tall the ellipse is. Okay? So I'm going to define these parameters at the bottom here because the definitions for these parameters are going to hold for both of these types of ellipses. So in both of these cases, A is the distance from the center to the vertices. Okay? So when I talk about vertices in the context of an ellipse, the vertices are the endpoints of the major axis.
So they're the absolute furthest point from the center?
That's correct, yeah, the absolute furthest point from the center that's still on the ellipse. So if I'm going to look back at my diagrams here, A is like this distance right here. That's A. And for the vertical one, A is right here. All right, now it's also this too. But if I start like labeling everything on here, it's just going to get too cluttered. So I just make a note that this is also A. B, scroll this up a little bit. B is the distance from the center to the what we'll call co-vertices. And these are the endpoints of the minor axis. So just like the vertices are the points on the ellipse furthest away from the center, the co-vertices are the points on the ellipse that are the closest to the center. So on your diagram, B is this distance right here. So in terms of trying to graph these ellipses, the strategy is typically find the center and plot that, figure out where A is, and then just go that many units out, and then find B and then go that many units out. You plot those 4 points, and then you draw your oval. There's one more piece to this, though. Now, we'll talk a lot more about this on our last day when we talk about the general form, and we start getting sort of more into the weeds here. But there are a couple of important points not on the ellipse, but that helped to construct the ellipse. So these points will be a little bit more important a little bit later on, but these points are called the foci. Okay, there's going to be 2 of them, and foci here is plural of focus.
Oh, I deal with these ones working with mirrors and astronomy.
So where are these foci? Well, the foci are going to be somewhere between the center and the vertices. They're going to be on the major axis, okay? They're going to be not points that are like on the ellipse, but that helped to construct it. We'll talk a lot more about this in the future.
A point that's a distance from the center that's that it has equal distance between it and the edges that's twice the distance it is from the center.
So on here, on this vertical one, the foci would be like here and here. Okay, so you might notice that like this point doesn't really like help you graph anything here. It's really more related to the actual definition of an ellipse. But for now, let's just define like how to find that coordinate. Okay, the focus is going to be C units from the center. Okay. So I'm going to write that at the very bottom here. So the foci are C units from the center. Okay, so that sort of begs a question here. Where's C? C is nowhere in our equation, right? So there is a relationship that exists here between A, B, and C. It might surprise you, but maybe not. I don't know. Okay. So C here, C squared is equal to A squared. And here's the truly unfortunate part. minus b squared. I know you kind of want it to be plus, but it's not. This is based on the Pythagorean theorem. It's just that the longest distance here is a. So, you know, c is, like if you were to construct a triangle, c would just be one of the side lengths. And what's sort of interesting here is if you look at the diagram, even though a is the distance from the center to the vertex, it's also the distance from the co-vertex to the focus. That distance is equal. That's kind of interesting. Yeah, so this is really the triangle where that formula is coming from. Oh, I told you there'd be no triangles, didn't I? So let's pull up Desmos again. And I'm going to just sort of alter what I have here. I'm not going to just start from scratch. I'm going to change this r squared to just 1. Oops. How did that happen? 1. Which means I don't really need r anymore. Okay. Now, each one of these, I'm going to, how am I going to do this on here? Let's see, divide, oh, that'll work. Divided by a squared. Oops. Not ae squared. Oh gosh. Come on. Oh, this is just getting worse and worse and worse. Oh, come on. Where's that e keep coming from? Okay, there we go. And then I need a b squared underneath here. This would probably be easier with a keyboard, yes. Whoa. All right, this is like, is this the problem here? Okay, I was, appears as though I was typing a bunch of stuff here. Maybe this will work out a little better. Trying to be all fancy here. Okay, so now the keyboard doesn't want to work here. That's not good. There we go. All right. Technical difficulties, of course. That is a lot of threes. All right, back in business here. All right, so b squared. I should have just been using the keyboard from the beginning. All right, so here we go. We've got all the parameters in there. And so just like with the circle, the HK is going to change the center. All right, if I make A bigger, that's going to widen my ellipse out like that, see? And if I change B, that's going to make it taller or shorter. So you can see if this number is bigger, like if that were the A, it would be tall and narrow. But if the number underneath the X is bigger, it'll be short and wide. Yeah. So we can use this to sort of like help check our answers as we sketch these graphs out. Let's do a couple of example problems, and then we can check it on here. Okay, so let's graph x minus 2 squared over 9 plus y plus 4 squared over 4 equals 1. Okay, so the first thing to do is just identify that, yes, this is an ellipse, right? This sort of is in that format. We should be good to go. So let's break down all of the components here. So where's the center? Let's start with that. Okay, so 2, -4. Now I'm going to just sort of hold off on graphing anything yet until we've analyzed this. So since the number underneath x is larger, is this going to be a tall and narrow or a short and wide ellipse? So since 9 is greater than 4, maybe a better question would be, is the major axis vertical or horizontal? Horizontal. Since 9 is greater than 4, the major axis is horizontal. Okay, so in that case, what's A? 3, right? That's the square root of 9. And what's B? 2. That's the square root of 4. So let's graph all these, and then we'll talk about all the coordinates. So to graph this, I'm going to put my center at 2, -4. So 1, 2, 1, 2, 3, 4. So there's my center. I'll probably have to extend this a little bit. My A value is 3. So I'm going to go right 3 and left 3 from the center. 1, 2, 3. 1, 2, 3. Plot those points. My B value is 2. So from the center, I'm going to go up 2 and down 2. So here's my ellipse. Yikes. That's pretty awful. I don't even know how to fix that. All right, so we'll put this in a Desmo so you can get a better picture of what this is supposed to look like. But there's one last thing that I want us to list out. Okay, I want to list out some of the important coordinates. Like, where are the vertices? What are the coordinates of the vertices? So that would be like this point and this point. 5, -4. Good. So just so that we can kind of get the vocabulary down. Where are the co-vertices? So that would be like this point and this point. So 2, -2. And what's the other one?
2, -6.
Okay, 2, -6. Okay, so those are the co-vertices. And the last thing would be the foci. So the foci are just sort of, right now, just kind of this extra thing that I'm making you calculate. Kind of a pain, but it is what it is. So to find the foci, remember that the foci are C units from the center along the major axis. So to calculate C, we're going to use that formula that I gave you, C squared. Let's see, so I'll leave a little space here. C squared equals A squared minus B squared. So in this case, C squared would be C rather, would be the square root of, now since we're dealing with A squared and B squared, and that's how the original equation is set up, you could just pull these numbers from right here. A squared is 9, B squared is 4, so what's C? Yeah, square root of 5, right? Now, so if C is the distance from the center to the focus along the major axis, I'm not going to make you, that's going to be like a decimal. The easiest way to write this is to say, all right, let's start at the center right? So the center is at 2, negative 4. And you can actually use this strategy for the vertices and co-vertices too. It's particularly useful when the number you're adding is not a whole number. But what do I want to do here? Like, I want to add root 5 going this way, and I guess subtract root 5 to go this way to find those other two coordinates. So I'm going to say 2 plus or minus root 5, negative 4. And those will be the locations of the foci. You know, they'll be about like here and here. So let's double check our work here in Desmos. So in this case, the h is 2. I'm just going to drag this slider over. I don't have to type anything. Oh boy. Maybe I will just type it. Maybe that'll be easier. Okay, the k. What was the k again? Negative 4? Yeah, negative 4 is going to be down here. Okay, my a value is 3. And my b value is 2. So let's see, does that kind of match, does that look, it kind of looks like our sketch there. Looks a lot better than my sketch for sure. But when you do this, you know, what I'm trying to get you to see is that this is a good way to check your answers. Just go on to Desmos, type it in, and see if it looks right. We could even plot the foci here if you really want to see where they are. So let's see, 2 plus root 5. Can we do a root 5 on here? Oh, yes, we can. All right, perfect. 2 plus root 5, negative 4. My syntax is messing up here. All right, so you can see where that point is right there. And the other foci would be 2 minus root 5, negative 4. You can see it's about right there. So that's where the foci are. Any questions so far? All right. Actually, I'm going to give myself more space here. Okay, so here we go. Determine the equation of an ellipse centered at 3, negative 1. Okay, so I'm giving you the center. That has a vertical major axis with a length of 5, so the whole major axis, not just half of it. And passes through the point (2, 0). So what's sort of tricky about this is that with this given information, I'm only explicitly or sort of explicitly given 3 of the 4 parameters I need, right? I've got my HK. I can sort of piece together what A is going to be here. The B part is what's going to be a little tricky. So if you're trying to envision like what is the given information here, it's centered at 3, negative 1. All right, so it's going to be right here. It's got a vertical major axis where the whole major axis has a length of 5. So what would be the A value here? What's the A value? If the entire, if I go back and I'd say, okay, well my vertical major axis, the whole thing is 5, then what's A? 2.5, right. Okay, so my A value is 2.5, meaning like I go up 2.5 and down 2.5. Okay, so 1, 2.5, down 2.5, roughly here. I'm just kind of getting a feel for what this is. And then it also tells me that there's a point 2, 0 right here. So that does not give me the information I need to find b. I mean, well, sort of implicitly, yeah, but it doesn't like immediately tell me, oh, b's this. Right, so let's sort of break down what we know. We know that the h is 3, we know k is -1, and we know a is 2.5, but b is sort of a mystery so far. So the strategy here is going to be to write out as much of the equation as you can first. Okay, so let's just, knowing that we don't really know what b is yet, we can sort of sketch out what this is going to look like. It'll look something like this. But let's write as much of the equation as we can. So we've got, here's the format we're going to be using. X minus h squared over b squared, right, because this has a vertical major axis, plus y minus k squared over a squared equals 1. So that's just the format I'm going to use. And I sort of know everything except for b here. All right, so x minus 3 squared over b squared plus y minus -1, so that'd be y plus 1 squared, over, I'll just say 2.5 squared. I'm not even going to bother squaring that yet.
Were you able to get that from the coordinates of the center?
Yeah, you got to remember that all equations are just a relationship between two variables, x and y, right? They produce the solutions to, the solutions to the equation are going to be points on the graph. So we actually know a coordinate on the graph, separate from a and all that, and that's the 2, 0. Right? This 2, 0 is just some sort of random point on the ellipse. What we can do, though, is we can plug that in to x and y, because that should be a solution to our equation, and then solve for b that way. And we almost don't even need to solve for b. We just want b squared, so we don't have to worry about like square rooting or anything. So yeah, let's try to solve for b. We're going to sort of basically do some side work here. Just work this out to the side and plug in 2 and 0 for x and y, where b is just going to be my leftover parameter. So I've got 2 minus 3 squared over b squared, that's really what I want, plus 0 plus 1 squared over 2.5 squared. And just for the sake of solving here, 2.5 squared is 6.25 equals 1. And so now I'm just going to kind of simplify this. I would let you use a calculator on this for sure. There's a lot of decimals flying around here. So we've got -1 squared, which is just 1. So 1 over b squared plus 0 plus 1 is 1 again, so 1 squared is 1. 1 over 6.25 equals 1. What's my next step? Yeah, you can't just like flip both of these. Yeah, you don't even, let's just, there's something else that would make this easier. Like, think of this as just like something plus something equals 1, right? Yeah, this is just a constant, right? So we could subtract that from both sides. And just do like 1 minus 1 over 6.25. Subtract that on both sides. And using a calculator, we can determine what that is. In fact, you might not even need a calculator. You're just doing like 6.25 minus 1. So 1 over b squared equals, let's see, this would be like 6.25 over 6.25. So 6.25 minus 1 would be 5.25. And you could get that from a calculator too. Yeah, that's okay. So here I just want to cross multiply and then divide. So I've got 5.25b squared equals 1 times 6.25. So b squared is equal to 6.2. Now, I'm not really liking how we got decimals and fractions here. Let's try to simplify that. I'm going to use a calculator here to try to simplify that. So what is 6.25 divided by 5.25? Looks like that's 25 over 21. So that's b squared. I'm not worried about going any further than that. I've got my b squared. Now I can sort of plug that back in to my equation. Yeah, it's kind of an ugly number, but it is what it is. So going back here, I've got x minus 3 squared over, I know what b squared is, it's just 25 over 21, plus y plus 1 squared over 6.25 equals 1. So it's kind of a weird problem, you know, but as long as you know the strategy, it doesn't have to be super difficult. You know, and you can use a calculator to help you out with these fractions too. Just throw it into Desmos, and really what's going to be the giveaway is whether or not this thing actually goes through 2, 0. So let's set up our parameters here. So I'm just going to kill off these foci. I don't really care about those at the moment. So my h is 3. My k is -1. My a, which really is my b here, the denominator of the first fraction, is, what did I say it was? 25 over 21. And then my b value is going to be 2.5. Uh-oh. That doesn't really look like it goes through 2, 0, does it? What's wrong here?
Did we happen to round the a squared? I think if anything, it has to do with our fraction reducing the
I got it. So the 25 over 21, that's actually the squared version of that, right?
so
Yeah, it should be the square root of that. So. Oh, I killed it. There we go. There we go. Oh, I did the double square root. Even worse. There we go. Oh, that looks much better. So there you go. It's right there. 2, 0, right on the money.